All right, let's try a couple of practice problems for quiz 1. So starting with problem 1, let's write 563 in expanded form. So that means we have to identify the place value for each digit. So starting with the 5 times something, the 5 over here I'll write down is in the hundreds place. And that means we're multiplying 5 by 100. And 100 is the same thing as 10 squared. So that is what I'm going to put here. So that is 5 times 10 squared. Next, the 6, if I focus on that, the 6 is in the tens place. And that means we are multiplying 6 by 10. And you can think of 10 as 10 to the first if you'd like. So that's what I'll put here. This is 6 times 10 to the first. And then for our last digit, this 3, that is in the ones place. So you could really think of this as 3 times 1. And 1 you can think of as 10 to the power of 0. And that's what I'll put here. In question 2, we're going to do this process, but in reverse. Here the number is in standard form, and I'd like to write it as a base 10 numeral. So essentially, you have to look across here and identify the digits of each place value. So first, I see this 10 cubed, and I know that is equal to 1,000. So this here must be the thousands place. And therefore, we have 1,000. I'll write that eventually over here, but let's go through and look at the remaining place values. Here, this is 10 squared, and so that means that this is the hundreds. Likewise, this 10 to the first must be the tens place. And lastly, this 9, it's not written, but you could think of this as 9 times 1, or really 9 times 10 to the power of 0. And for this reason, this 9 here is in the ones place. So we have 1,229, and that is the answer here. That is 1,229. In question 3, I'd like to convert the number 21 base 5 into a base 10 number. The way we do this is by expanding out this number using the base. So that is, if we start with 21 base 5, I'll note that this 1 is in the ones place, or really could think of it as 5 to the 0 because that's equal to 1. And this 2, well, that's in the fives place because that's 5 to the power of 1. Therefore, if we expand this, we take the digit and multiply it by its place value. So that will be 2 times 5 to the first added to 1 times 5 to the 0, which is also 1. If we simplify this, this will be a base 10 number. That is 2 times 5 plus 1 times 1. 2 times 5 is 10, 1 times 1 is 1, and then 10 plus 1 is 11. For emphasis, I'll note that this is base 10, and that is the answer for question 3. For question 4, we're going to do this process in reverse. We're going to start with a base 10 number and change that to something that is in base 7. So what we're looking for here is we have 41, which is in base 10, and I'd like to convert that to a base 7 number. To do this, I ask myself, is there a number I can multiply 7 by that gets me very close to 41? And I'm only allowed to use digits from 0 to 6. I can't use 7 or anything greater than 7 because we want to go to base 7. So 7 times 6 is 42, and that's too much, but 7 times 5 is 35. So here, what I'll do is I'll say 41, which is in base 10, is equal to 5 times 7, provided that we add something to this. This is 35, and you want to get up to 41, that means we have to add 6. Now, how does this actually help me get to a base 7 number? Well, here I have 7, and that's 7 to the first. That means 5 is in the sevens place. Over here, I'm not quite sure what place value this is in, but what I can do is I can rewrite this all as 41 base 10 is equal to 5 times 7 to the first, the 7th place, plus 6 times 7 to the 0. 7 to the 0 is 1, and that's equal to 6 all by itself. Here I can read off the digits 5 and 6 to determine the base 7 number. In fact, 41 base 10 is equal to 5, 6 base 7. The 5 and the 6 came from this 5, which is in the 7's place, and this 6, which is in the 1's place.